This question is about organic compounds containing nitrogen. Part A, sodium cyanide can be reacted with many organic compounds to increase the length of a carbon chain. Part 1, 1-chloropropane reacts with ethanolic sodium cyanide by nucleophilic substitution. We're asked to outline the mechanism for this reaction, include curly arrows, relevant dipoles, and the structure of the organic product. For any mechanism, we need to start by drawing our reagents. Nucleophilic substitution is one of the 5 mechanisms that you need to know because it can come up in any organic exam and potentially a unified exam. Here I've drawn my reagents. We get a mark for the curly arrow from the cyanide, which acts as our nucleophile to the carbon, and that's because of the induced dipoles. There's also a curly arrow from the carbon-chlorine bond to the chlorine. Then, in the final stage of the mechanism, we need to show that the length of the carbon chain has been extended, and this is because the cyanide bonds instead of the chlorine, so we get a chlorine ion at the end. So, to clarify, we get a mark for our curly arrows, a mark for the dipoles, and a mark for including the chloride ion in the final stage of the mechanism. Part 2. Compound G is used to synthesize compounds H and I, as shown in the flowchart below. Complete the flowchart showing the structure of compound G and the formulae of the reagents for reaction 2 and 3. If we start by trying to find compound G, reaction 1 is a nucleophilic addition reaction. A nucleophilic addition reaction is between a carbonyl group and will either form an alcohol or a hydroxynitrile. In this case, we formed a hydroxynitrile. So our carbonyl group, which is a C double bond O, will be an aldehyde, and it will have a hydrogen as its R group because the CN, without it, there's only one carbon in the molecule. Then, looking at reaction 2, it's a reduction reaction, which means we need a hydrogen, or hydrogen gas, and a nickel catalyst. Then, reaction 3, the cyanide group has turned into a carboxylic acid. For this to occur, we need an aqueous acid, for example, hydrochloric acid. But sulfuric acid would also be accepted, as long as the formula is correct. For this question, you get a mark for compound G, the reagents for reaction 2, and the reagents for reaction 3. Part 3. Compound H reacts with dilute hydrochloric acid to form a salt. Explain why compound H can react with dilute hydrochloric acid and suggest a structure for the salt formed. Well, compound H, which I've drawn so we don't need to refer back, has a nitrogen. And nitrogen would have a lone pair. So the nitrogen lone pair will accept a proton. We can write the proton as an H+, and that will help with our structure because the salt will have an NH3+ group, and then to make sure that it's a salt we need to balance the charge, and we can do this. With hydrochloric acid we've got the chloride ion, and there together would make our salt. For this question, we get a mark for our explanation of the nitrogen lone pair accepts a proton, and the correct structure for the salt for this question. Part 4. Compound I is the monomer of the biodegradable polymer J. Draw 2 repeat units of polymer J and suggest a reason why it's biodegradable. In compound I, which I've drawn above, we've got a carboxylic acid group and an alcohol group. So if I just show these, our carboxylic acid group is here and our alcohol group is there. Therefore, in our polymer, we would have an ester link. Here I'm just drawing what an ester link looks like. Then if we work backwards, the single O here, that comes from the alcohol group, and so will be attached to a carbon with 2 hydrogens. And the carbonyl group, or carbon double bond oxygen, would also be attached to a carbon with 2 hydrogens. Then if we complete this polymer, we only need to draw 2 repeat units, like so. Now, you don't have to write brackets and a n for this question, but it's really useful too, because a lot of questions, they can have it in the mark scheme, some don't. So to be on the safe side, it's useful to draw your brackets in an n, because you won't lose marks if you include them, but you could if the mark scheme says to. If it doesn't, it's not going to affect anything, it just says to ignore them. So I'd recommend always including them when drawing polymers. Suggestion why it's biodegradable: an ester link can be hydrolyzed, and it can be hydrolyzed in acid or base hydrolysis. So for this question, you get 2 marks for the polymer and 1 mark for saying that it can be hydrolyzed. B. The repeat unit of nylon 6,6 is shown below. Part 1. Draw the structures of the 2 monomers that can be used to form nylon 6,6. In nylon 6,6, we've got an amide group, or link, as it's known in polymers, which means we're going to use a carboxylic acid and an amine. It's a condensation polymer, so that means that we're a byproduct of this process, we would form water. This is not useful in the question, but it's good to have in the back of your head when checking. So, our carboxylic acid, well, we can already see where it's going to come from based on the polymer. It's going to come from this section of the molecule. And so we can just draw the remaining parts of the polymer, but as carboxylic acid groups. Just double checking we've got the right number of carbons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Then, drawing our second monomer, we would have our amine, so nitrogen with 2 hydrogens, and then our carbon backbone, and again our amine. Double checking our carbon backbone is the same length, because this is where a lot of people would stumble up in the exam. 6 carbons, 1, 2, 3, 4, 5, 6 carbons. These numbers aren't critical in the exam, so we can now erase them. For this question, we get a mark for each monomer, and that will get you 2 marks for this question. Part 2. A sample of nylon 6,6 has a relative molecular mass of 21,500. Estimate the number of repeat units in the sample. Give your answer as a whole number. Well, we can first work out the relative formula mass of our nylon 6,6 sample that we were given in the question or part above. So relative molecular mass, that would be counting the number of carbons and timesing it by its relative molecular mass. There are 12 carbons in this molecule. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, plus 2 oxygens and 2 nitrogens. And then we need to count the number of hydrogens. And when we count them, there are 22. This gives us a relative molecular mass of 226. So we can take our 21,500, divide it by 226, which gives us 95.1. But in the question, we're told we want the answer as a whole number. And so the number of repeat units is 95. So writing 95, that gets you the marks for this question.